All right, so now you've got this blue paper, something that says z-scores and z-score formula. Go ahead and do me a favor, and I'm gonna fold that hot dog style. And then once you do that, we're just gonna slice it right down the middle. So this video is gonna be covering this half. We're gonna save this half for the next video. All right, let's just get into it. So this video is all about z-scores. And so z-scores are helpful when we don't have like really nice standard deviations or nice changes. What is a z-score? A z-score is a value that shows how many standard deviations a data value is from the mean. Hope you can see that. Let me make it closer. So if I were to give it like a picture, we have our normal distribution. We know that this value was our mean. The z-score tells you how far away it is from the mean. If it is a positive z-score, we are to the right. If it's a negative z-score, we are to the left, or we are above the mean, or we are below the mean. Below. And then if it says 0 and it means how far away we are from the mean, well, if we're 0 away, that means we're directly on top of the mean. So like this would be 0. All right, so there's a formula that looks like z equals our data value, taking away the mean, divided by standard deviation. And so this lays everything out. Let's open it up and start practicing. A radar detector records the speeds of a group of cars that pass by. If the mean is 46 miles per hour and the standard deviation is 2.8 miles per hour, find the z-scores for each value. So we know that the mean is 46 and the standard deviation is 2.8. All we gotta do is use these x values. So these are all gonna be like x equals, x equals, x equals. Since x equals 52, we're gonna put it into that formula that z equals x minus mean divided by standard deviation. So in this case, we've got the z-score is 52 minus our mean 46 divided by 2.8. 52 minus that would be 6. And then when we type that into a calculator, I think you get 2.14. I don't see a calculator with me. Let's find a calculator. Divided by 2.8. Yeah, 2.43-ish. I'll just leave it as 2.14. Next one. Oh, so this means it's 2.14 standard deviations away from the mean. So in our normal distributions, now we're considering it to be, if this is mean, and this is 1 standard deviation, 2 standard deviations away, 3 standard deviations away. This is also the same thing, just in the negative direction. This 2.4, maybe I'll color code. 2.14 says it lies somewhere in here. So do you remember that video where we're talking about, like, we don't know exactly where it is, but it's roughly in a certain spot? That's what the z-score is telling us. It's exactly how far away from the mean we are. Let's do the next one. So this would be z equals 42 minus 46 over our standard deviation 2.8. We get negative 4 divided by 2.8. And we got about negative 1.43. So this one's going the other direction, and it's somewhere in this spot. Somewhere underneath the negative 1 standard deviation away. Next one. Point 36. And so this one is really close to the mean. It's on the positive ends. There's positive, negative. It's going to be somewhere like right here. All right, now let's do some word problems. The mean number of total miles ran last week by each member of the track team was 4, with a standard deviation of 1.2. If Clay's z-score was 2.5, how many miles did he run? Well, let's talk about all the pieces of the information that we currently have. We know that the mean was 4. Standard deviation was 1.2, and his z-score is 2.5. So what are we missing in this data? We're missing the data point. So we're trying to figure out how many miles he ran, or we're trying to find out the x in that equation. So we can set up everything as normal. It's z, 2.5, equals x minus mean. Well, we don't know what the x is, so we'll leave it as x. Take out 4, put that all over 1.2. And so now we're just going to figure out what x is. I'm going to start by multiplying by 1.2 on both sides. That way those go away. I don't know what 1.2 times 2.5 is. 1.2 times 2.5, 3. Well, that's nice. And then we're going to add 4 on both sides. And we get x equals 7. So what does that mean? Clay ran 7 miles last week. All right, let's do next one. A set of test papers is normally distributed with a standard deviation of 5. That's important. If Riley scored an 83 with a z-score of negative 0.4, what was the mean? So we've got mean, standard deviation, data point, and our z-score. Our standard deviation was 5. He scored an 83, so that's a data point. And a z-score was negative 0.4. We are curious about what the mean is. Let's do the formula. So we're going to do our z-score, negative 0.4 equals, it's x minus mean. So we're going to do 83 minus, I don't know what the mean is, so I'll leave it as mu, divided by our standard deviation, which is 5. And so now we're going to solve this through. I'm going to multiply both sides by 5. That way those go away. 5 times 0.4 would be 2, so it's going to be a negative 2, equals 83 minus mean. Now you can do it longhand like that, but the only value that would make sense right here, 85 take away something gives me a negative 2. This would mean that our mean, needs to be 85, because that's the only way we're going to get negative 2 there. So the test paper mean, or the mean test score, average test score was about an 85. Unfortunately, poor Riley scored under the average, so that curve isn't going to help him as much as it would if he scored higher. Okay, number 4. Last one of the video. We got this. The height of a group of trees is normally distributed with a mean of 14.3. So on average, that's how tall it is, how tall the trees are. If a z-score of a 20-foot tall tree is 1.9, what is the standard deviation? So let's lay everything out. We have our mean, our standard deviation, our data point, and our z-score. So the mean's 14.3. Standard deviation, we don't know yet. The z-score is 1.9. And then we're looking for like our data point. It's talking about one tree has 20 feet tall in height. So now we can figure out what the standard deviation is going to be. 1.9 equals our data point minus our mean, all divided by standard deviation. With some finagling, we can multiply it by standard deviation. (20 minus 14.3), will that give me 5.7? I'm going to divide both sides by 1.9. That way those will get away. So now I have to figure out 5.7 divided by 1.9. 5.7 divided by 1.9. We get 3. So what is this? The standard deviation of tree heights is 3. Cool. So in summary, this was like a how-to on finding z-scores. Z-scores tell you how far away from the mean you are. And so that's going to come in handy for the next one. We're trying to figure out probabilities. It tells you what positions you're at. If you remember with empirical rules, these ones are like, what if happens if everything is 1 standard deviation away? But sometimes our standard deviations aren't really nice or not really neat. So this is going to tell us like the exact location on those normal curves. Wait, bye.